Hello children, in this lesson we are going to cover the topic properties of rational numbers, which is a part of our first chapter, rational numbers. So at the end of the lesson you will be able to list and describe the properties of rational numbers, apply and identify the properties of rational numbers. So let's start our topic, properties of rational numbers. The major properties of rational numbers are closure property, commutative property, associative property, distributive property, additive identity, and multiplicative identity. Let's discuss them one by one. So our first property is closure property. Closure property says if P and Q are any two rational numbers, then the sum, difference and product of these rational numbers is also a rational numbers, which means for any two rational numbers, the result of addition, subtraction and multiplication gives a rational number. Rational numbers are closed under addition, subtraction and multiplication, which means rational numbers follow closure property for addition, subtraction and multiplication only. The division is not under closure property because division of any rational number by 0 is not defined. Now let's come to our second property, which is commutative property. If P and Q are two rational numbers, then commutative law under addition says P plus Q is equals to Q plus P, which means in the case of addition, changing the order of given rational numbers does not change the result. For example, the sum of 1 by 3 and 2 by 3 is equals to the sum of 2 by 3 and 1 by 3, which is 3 by 3. Similarly, commutative law under multiplication says in the case of multiplication also, changing the order of rational numbers does not change the result. For example, the product of 1 by 5 and 2 by 3 is equals to the product of 2 by 3 and 1 by 5. In simple words, this property states that order does not matter in the case of addition and multiplication. Rational numbers are commutative under addition and multiplication only, because in the case of subtraction and division, changing the order of rational numbers change the result. That is why rational numbers are commutative under addition and multiplication only. Now come to third property, associative property. If A, B and C are rational numbers, then associative property under addition says in the case of addition, the order of grouping can be changed and it does not change the result. For example, on both the sides, we have same rational numbers 5, 3 and 7. But the order of grouping is changed. Still we have the same result, which is 15 on both the sides. Similarly, in the case of multiplication also, the changing of order of grouping does not change the result. For example, again, we have same rational numbers on both the sides, which is 2, 3 and 5. We have changed the order of grouping, but on both the sides, we have 30 as answer. The result is 30 for both the sides. In simple words, you can add or multiply rational numbers regardless of how they are grouped. Rational numbers are associative under addition and multiplication only, because in the case of subtraction and division, changing the order of grouping of rational numbers change the result. Now come to distributive property. Distributive property of multiplication over addition. If A, B and C are any three rational numbers, then A into B plus C is equals to A into B plus A into C, which when we multiply the sum of two rational numbers by a given rational number, is equal to the same result when we multiply each rational number by the given rational number and then add the product together. For example, 3 into 5 plus 2 will be equals to the sum of 3 into 5 and 3 into 2. Distributive property of multiplication over subtraction. If A, B and C are any three rational numbers, then A into B minus C is equals to A into B minus A into C, which means when we multiply a difference of two rational numbers by a given rational number equals to the same result when we multiply each rational number by given rational numbers and subtract the product together. For example, 3 into 5 minus 2 will be equals to the difference of 3 into 5 and 3 into 2. 0 is the additive identity for rational numbers. Since adding 0 to any rational number does not change the number, that is why 0 is the additive identity for rational numbers. 1 is the multiplicative identity for rational numbers because 1 helps the number to retain its identity. Now we will discuss some questions from exercise 1.1 which are based on the properties of rational numbers. So we are discussing question 5. Question 5 is, name the property under multiplication used in each of the following. First part is minus 4 by 5 into 1 is equals to 1 into minus 4 by 5 is equals to 4 by 5. So as you all know, 1 is the multiplicative identity for rational numbers and it helps the rational number to retain its identity. So the property used is property of multiplicative identity. Now come to second part. In second part we have minus 13 by 17 into minus 2 by 7 is equals to minus 2 by 7 into minus 13 by 17. Here commutative property under multiplication is used because in this question order of rational number is changed. That is why commutative property under multiplication in this case. Now come to third part. Minus 19 by 29 into minus 29 by 19 is equals to 1. As you know, when the product of two numbers is 1, they are called multiplicative inverse of each other. That is why property of multiplicative inverse is used here. Now come to question 7. Question 7 is, tell what property allows you to compute 1 by 3 into 6 into 4 by 3 as 1 by 3 into 6 into 4 by 3. In this question, order of grouping is changed in multiplication. Here 6 and 4 by 3 are grouped together. Here 1 by 3 and 6 are grouped together in multiplication. Therefore, we will use commutative property under multiplication. Now this is your homework for the day. Using appropriate property, find the value of the following. So you need to use the property which we have discussed today and you will find the value for these two questions. These are the references. Thank you.